Hi everyone, my name is Defa Ansokal and welcome to this session. We're going to learn how to build ARIMA models using R, and in this session we are going to use air passengers data, which is an inbuilt data set in R. First, we're going to load air passengers data using data function. The next thing is you are going to view how this passengers data looks like. We are going to use the print function. Now this air passengers data, it looks like this. It runs from 1949 to 1960 and it runs from January to December for each year, having each entry. The next thing we are going to do is to check if air passengers data is of time series class, and we are going to use is.ts function, and it returns true to mean that this data is of time series class. And then you can also use class function to view if it is a time series object, and it returns TS to mean it is of time series object. The next part is we are going to load two packages that we are going to use. We are going to load forecast package and T-series package. The next thing, we are going to plot this air passengers data. It's a rough plot of this data to see how this data looks like. And we use plot function. If we plot, we will see that there is up and downward trend on this data. That is from 1949 to 1960. Then the next thing we should note about time series data, it behaves in three ways. We have the seasonality, autocorrelation, and stationarity. For autocorrelation, we are going to conduct this on passengers data, and we use a CF function. We are going to use a CF function on air passengers, and if you use that function, this is the plot you will obtain. You can see that there are many lines crossing the blue dotted line to show that this data is highly correlated. And then the next thing we are going to do is to conduct partial autocorrelation on our passengers data. And you can see, if we conduct partial autocorrelation, you can see there are still few lines crossing the blue dotted line, which will not be the case. And then the next test we are going to do is the test of stationarity. It is called augmented Dickey-Fuller test, abbreviated as ADF test. We are going also to conduct this on air passengers data. And if you conduct that, you will see on your R console that we have a Dickey-Fuller value negative 7.3186. We have p-value of 0.01. So to conclude that your data is stationary or not stationary, p-value should be less than 0.5. And as you can see, our p-value of 0.1 is less than 0.5. So our data set is stationary. The next thing we are going to do is to build our model, and we have various criteria we use to select the best model. And these criteria may be Presby criteria, they can be archaic information criteria, they can be Schwarz Bayesian information criteria. But on this particular case, you are going to use archaic information criteria, abbreviated by AIC. And we are going to use also auto ARIMA function. So this auto ARIMA function, you are going to use it on air passengers, and IC means information criteria, which in this case is archaic information criteria, and trace equals to true. If you run that, if you run that, there will be different displays on your R console. Just give it time to display all the values. Something you should also note that in archaic information criteria and Bayesian information criteria, the best model will be that model with the least value of archaic information criteria and Bayesian information criteria, which in this case the best model is that of ARIMA 011 and ARIMA 210. So if you want to view your air passengers model, you can view it and you can see we have archaic information value and Bayesian information value, and in all those cases there should be the least values. So the next thing we are going to do, now that we have our passengers model, we are going also to check if this air passengers model, is it really stationary or is it not, or it is not. We're going to conduct autocorrelation together with TS function on air passengers model and residuals. And if you do that, this is how your model, how your plot will look like. You will find that at least only one line crosses the upward dotted line, and in the downward blue dotted line there is no line crossing it. And then the next thing we do is to perform partial autocorrelation on air passengers model and residuals. Now if you perform that, the output will look like this. Now from here you can really see and clearly see that our air passengers model is stationary. Now from here we are going to use our forecast function, and what we want to forecast is air passengers model, and we're going to forecast it at a given level of confidence, which is 95%, and we are going to forecast it for the next 10 years, and these years it is quarterly. So that's the syntax. And if you run this, if you run that and you view your air passengers forecast, you'll see that we have point of forecasts for each year, and low 95%, that is the lower limit of 95% confidence, and high limit of 95% confidence. Then the next thing we are going to plot this my air passengers forecasts now to see how this model would look like in the next, how it will behave in the next years. So we'll use plot function to plot my air passengers forecast, and we'll name our x-axis to be year and our y-axis to be number of passengers. And if you run that, you'll have this. You'll see that the trend will continue in the years to come, and from this you can advise the organization that when the number of air passengers increases, they should increase the number of flight attendants, or they should also buy more planes. And when the number of air passengers decreases, the opposite should be true. And then the last part in model building is to check for model validity. Model validity refers to the stability and reasonableness of a regression coefficient, its plausibility and usability of the regression function and the ability to generalize inferences drawn from the regression model. So to check for model validity, we are going to use box tests, and this test I apply it on my air passengers forecast and residuals, and lag equals to 5, and the type will be L-junk box. By this test, it is used to check for model validity as well as checking for autocorrelation if still there is some autocorrelation in your model. So if you find a p-value greater than 0.5, it means that your model is valid and there is no autocorrelation. So with this one, if we set our lag to be 5 and we run it, we'll see that our p-value is 0.486, which is less than 0.5, meaning there is still some autocorrelation in our model. So to do that, we're just going to increase the number of lags. If we increase the number of lags to be 15 and run this, we'll see that we'll have a p-value of 0.632, which means that our model is valid.